Hi folks, I'm Custom Chess for Roma Custom Bike and I welcome you to the second episode of the Triumph Project Build, the special bike based on a speed triple. In the previous episode we did demolition and we rebuilt the tail end out of sheet metal. In this episode we'll take a look at the design, machining and refining of the new parts that we'll be making for this project. In the next episode, the third, we'll take a look at the Arduino-based electronics that we'll be using to power the new accessories. And last but not least, in the fourth episode, we'll take care of the paint job, assembly and unveiling the bike to the owner. So be sure to stay tuned and follow the links in the description to find all the episodes in this series. In the last episode, while working on the tail's sheet metal, I created a cardboard template for the tail light. He helped me with space management during fabrication and now I need to turn it into a final product. I start by digitalizing the outline of the cardboard template to always have a reference of the available space. Then I like to add the mandatory objects, like the seat lock that we have saved from demolition. Once all fixed parameters are set, it's time to start with the creative design. I've decided to include all lighting functions in the tail light: the marker light, the stop light and the turn signal. To get this result, I decided to use two rows of LED lights, the top one for the brake light and the bottom one for the turn signals. I start by drawing the 26 LED lights that constitute the two rows. The first 5 LEDs from both sides of the bottom row will be yellow for the signals. The rest of them will be red. With the limited resources at my disposal, I had to figure out an accurate system to install all those LEDs in a small space and with the needed precision. I decided to use a dual-sided PCB board so that I could solder all the cathodes onto one side and control the signal to the anodes independently on the other. We'll get into more detail in the next episode where we'll be talking about all the electronics of the projects. Now, let me do a little consideration about CNC machines and their limitations. Even though the objects that they create are actually 3D objects, most machines have 3 axes and can be considered like 2.5Ds. That's because they can move freely onto 2 dimensions, X and Y, but they have limited control over the Z axis. Without a 4th or a 5th axis, the end mill can only plunge onto a stock at 90 degrees. For example, my CNC couldn't plunge diagonally into a piece. So, with these limitations in mind, I decided to split the tail light in 2 halves, split horizontally. This way I can carve the necessary pockets to house all the electronics. Starting with the outline of the bottom half, I extrude a solid object. This represents the stock from which we'll be carving the final product from. I've already prepared a 3D model of the PCB with all the LED lights on it so that I can use it as a visual aid for the designing process. This could be also done mathematically, but this way I'm less likely to make a mistake. To install the PCB inside the tail light, I create a pocket in the aluminum block. In 3D softwares, this is usually done by subtracting one solid from another. Then I add 2 spacers. This will allow the PCB to be fastened to the casing while leaving enough space for the components and for the wiring. Now I have to figure out a way to design the backside so that the light can be seen. As I've mentioned before, my machine can only plunge vertically onto the piece, so I need to come up with some other solution to work the backside of the tail light. I figured I can make a flat plate with holes for the LED lights and curve it against the shape of the casing. To do this, I create another pocket that can generate an edge that I can use as a frame for bending the plate. The process is then repeated for the upper side. The differences in design are dictated by the necessity of accessing the circuitry, the position of the frame bars, and the relative position of the mounting bolts. Summing and subtracting solid from the original stock, I finally reached the end product. This process of subtracting areas from a digital solid is not so different from what we're going to do later with the CNC machine, nor from what a sculptor does. So, to quote the great artist Michelangelo, also an Italian, every block of marble already contains a statue. The sculptor's job is to discover it. Well, for me, every block of aluminum contains some crazy ass shit, and Custom Chess is here to rip it out! Yes! With a similar technique, I also created a part that can combine style and functionality, while accenting a prominent feature on the bike, the radiator. It will provide better illumination to the area immediately in front of the bike, rarely lit up by stock lighting, and the turn signal function. This accessory is made out of two pieces carved in such a way to conceal the electronics, just like in the taillight. All the different pockets are staggered to allow support for the different layers of components, first the PCB, then the covers.
One step and were you and I, no ordinary day. Everything changes when I'm with you. The words you say just feel so good.
The two pieces match together, making an L-shaped object that will cover the outer edge of the radiator.
Time is like the first time.
I also had to create some communicating passages for getting the wires from one piece to the other. I think I already got quite technical in this episode, so I will not bore you with the toolpath creation process. We'll see that maybe in another episode. For now, let's get to the machining and the final hand job. Let's get to the happy ending. Well, no, the concept is just not translating properly. The joy of finishing up with your own hands. Well, fuck it, never mind, I give up.
I surrender. I've never been so alive. Just kiss me one more time before I go before.
While the machine finishes up, I would like to remind you that this channel exists because of you and your support. We are going to keep posting English videos on this channel for the next few months, but we are also separating the Italian channel from the English one because YouTube is just really not yet equipped to tailor the needs of a multi-language channel such as ours. So, in the next few months, we will be moving the English videos to a new channel called Custom Bike. I invite all of you guys to please subscribe to it by clicking right here or the link in the description. Please help us out by sharing our new channels and our videos in your social networks, because that's how we keep growing and we keep going. So, now that the machine is done, let's get our hands dirty. People tend to think that machining stuff means that the computer and the CNC do most of the work. In reality, it's nothing like that. You have already seen how much time and planning goes into designing the part, and even after the machine is done, I still have to take care of all the detailing and final refining by hand. These are how the pieces come out of the machine. The useful parts are still attached to the aluminum stock. Those little tabs that you see are needed to keep the part fixed to the table all the way to the end of the machining process. In more advanced machines, the workbed is equipped with a vacuum pump that can keep the piece stable without the use of those tabs. This is not my case, so I need to remove them using a nibbler, a type of shear designed to keep edge deformation to a minimum. parts are now free from the stock, but don't match together properly because they're still too rough. With my usual abrasive sponge, I smooth a bit the corners, made very sharp from the accuracy of the machining process. Then I remove the tabs. They're quite thick this time because of the size of the pieces. To do so, I use a file, a coarse one. It saves some time, but it can make some major damage, so watch out. I finish up with a sponge until there is no longer any sign of the tab. The process is repeated for all the other pieces. I keep them in my hand so I don't risk marring them in the vise. Another limitation of the CNC machine is the impossibility of creating a sharp inside corner. The smoothing of said corner is always dependent on the radius of the end mill used to carve the pocket. So pieces such as this one need to be touched up by hand or I won't be able to clamp the two pieces together. In the machine part, this corner is rounded. It should be a 90 degrees angle, like we can see in the 3D model. So it needs to be worked by hand with a file. This process needs a lot of patience. I have to keep the lines as straight as possible or the mistake will be visible in the final product. The same problem is in this other point, but this time we have to round the male insert to fit into a rounded inside corner on the other side. By rotating the file continuously, I try to create an even curve between the two planes, and I keep on grinding. Nobody can say that these parts are not handmade. When it's getting close to be good, I start doing matching tests and final touch-ups until the two parts fit together perfectly. Now it's time to make the threaded holes to bond the two parts together, and since my CNC machine cannot do side carvings, this also will be done by hand. The bench drill helps keeping things perpendicular. I bought this drill for about 60 bucks about 6 years ago, and it has served me well. Now, it's not the most accurate thing in the world, but with a little care, it's accurate enough. The holes now need to be threaded, and let me tell you, I hate threading holes. I hate it, I hate it, I hate it. 1 out of 4 times I mess it up. Maybe you guys can give me some tips. But anyway, the holes are done and the parts match perfectly. In the meantime, I've also machined all the brass inserts for the turn signals, the LED retainer bar for the taillights, and a piece for Polski's bike, but we'll talk about that in an upcoming episode. Just like all the aluminum parts, also the brass parts need to be freed from the stock and cleaned up. Here is a first glimpse at what they look like, and I would say it's coming out pretty cool. The same cleanup process was done for the taillight, and now it can be installed on the frame of the bike. I first removed some more plastic to make it fit.
We seem to want the glory, we seem to want to earn respect, but what it takes to get that done.
Beside the obvious lighting functions, this taillight serves the important purpose of closing and framing the tail end of the bike. The lines have to match perfectly, and as you can see right now, they're not. But that's what I wanted. Yes, because since the firing was made by hand, I knew that I could not match the shape with a computer-made model. And so I figured out that I would make the piece bigger and I'd bring it to size by hand. As you can see from the trash bin, I had to fuel with plenty of beer Jacek's help, but let me tell you, his help is always priceless. So we grabbed 2 files and we started to create the curves to match precisely the curves of the sheet metal.
Not when you're told, then you'll be fine. But
I don't really want to spoil the surprise by showing you too much, because still we have to cover all the electronics part in the next episode, but this is what we will be making.
just one sign that tells me I'm not alone. Give me just one.
Not too shabby, right? To get to the point, we'll have to develop the Arduino-based control board to manage all the LED lights and turn signal. We'll even have to do some waterproof testing for our electronic components, so that's not too bad either. In the 4th and final episode, we'll also paint, assemble and unveil the bike. So, to be sure to receive the notification for the new videos, please subscribe to our channel and remember to like and share the videos to help us grow. Thank you so much to CreArt for the great opportunity. I am Custom Chess and I'll see you in the next episode of Roma Custom Bike.